Question number 3. Let's factor x minus 4. In the denominator, let's factor. What are the factors of 8? Negative 8, yeah. What are the factors of 8? 4, 2. Okay, so let's do 4 and 2. So I have x, 4 and 2. Higher number 4 will be the same sign with the middle term. Middle term has negative sign, so negative, and opposite here, plus sign. Do we have anything to cross out? Shook. Yeah, what happened there? There is a hole. What's the location of a hole? What's the x coordinate? 4, correct. What is the y coordinate? I don't know, so let's cancel and let's simplify and use the simplest form, okay? After you cancel everything on the numerator, you have 1 on the top. In the denominator, we have x plus 2. So let's plug 4 here and let's find the number. What is that number? 1 over 6. 4 and 1 over 6. 4 and 1 over 6, very, very small number, right? Around there, I have a hole, so I graph hole. Otherwise, I may forget, so let me draw hole again. 4 and 1, 6, that is very small number near 0. I have a hole, I exaggerated. And now let's talk about other things. What do I need to talk about this guy in the denominator? That is another excluded value, but it is not cancelled out. What happened there? What happened there? Vertical asymptote, right? Give me the equation of the vertical line. If we are starting with the y variable, that's wrong, okay? Vertical asymptote looks like y-axis, but variable is not y. What is the variable? X. Look at the denominator. What do you have? X. So x equals, what's the number? Negative 2. Very good. So from the other factor, which is not cancelled, you can find vertical asymptote. X is at negative 2 and draw vertical line. So that is vertical asymptote. Let's talk about horizontal asymptote. So let's see what is the degree of the polynomial. What's the degree of numerator polynomial? 1. What's the degree of the polynomial in the denominator? 2. Which one has higher degree? Higher degree on the denominator, right? Denominator. And then what is going to be horizontal asymptote? Bottom is heavier, okay? The denominator has higher degree. It's just like parent function. What was the horizontal asymptote of the parent function? Y equals 1 over x. That is parent function. Parent function look like this. Here and then there. And which is a horizontal asymptote? Here, which is x equals 0, okay? So automatically when you have higher degree on the denominator, horizontal asymptote will be always y equals 0. Y equals 0. Don't make confused, okay? A horizontal asymptote looks like x-axis, but what is the variable we are using? Y. Okay, you use different variable. So let me exaggerate. I need to draw a line along my x-axis, but this one, yeah, let me draw a little bit longer so you can see the end. So this will be my horizontal asymptote. And now let's draw a curve. So one here, the other here, right? But I'd like to see all the numbers quickly, so let's use a calculator once again, and let's use ordered pairs. calculator. Y equals, let me clear all, and then let's put third one on the numerator. Second, no, not second, sorry. Alpha y equals, hit enter. On the numerator, you have x minus 4. In the denominator, you have x squared. Subtract 2x, subtract 8. Alright. Double check, triple check after you put a function. Okay. Graph. Okay. And then second graph. Oh, I don't like fractions. So let's go back and then let's put 4.0. Instead of 4, let's put 4.0 and go to your table, and we have all in decimal, right? I have a -2 error, and what was the other variable? 4 error. Oh, that was the number, right? Okay, let me copy and paste it here. Alright, so I can graph. At -4, this error means a hole, okay? This is a hole. And here you have vertical asymptote, okay? So let's use all good numbers. Which one is good to plot? -1 and 1, -1 and 1. Good. And another good number. 0 and 0.5, okay, 0 and 0.5, and then I think I can connect this. So let me connect this, and do not touch asymptote when you graph, okay? Exaggerate little bit, yeah. Oh, we touched already. Let's do it again. Right, exaggerate little bit, it should be above. Oh, look at that. I can graph. Let's draw nice and smoothly. And do not touch that. And then this is my hole. I exaggerate hole a lot. And the other side, -1 and, yeah, that's not good number. So let's look at the calculator and pick better number. Which number would be good? -3 and -1. Okay. I have -3, -1, that's good number. Plot the point and then just connect. Alright, so this is the other half of the curve. So we have always two parts on the rational function, okay? So on both graph, if you have at least 3 points, that's a good graph. So use at least 3 points. I plot the points on the exact location. So that's called the reference points, and the other parts, it's okay, alright, it doesn't need to be exact. Exaggerate a little bit at the end, yeah, it just look like overlapping, but try to draw a little bit above or below, then asymptote, so it doesn't touch the x-axis or here vertical asymptote.